Okay, next problem on page 399, problem number 5. Looks just like this. And the question says, find the slope of the line in the graph at the right. So guys, a couple of things. Remember, first of all, slope, just taking a look here. Remember just the idea that it's the steepness of the line. All right. So I always say, and I've seen actually posters that look like this. Think about if there's a man walking down that, and you want to think how hard is it or how easy is it to walk up or down that. So when the man walks, I always say just you're walking left to right. So you're going to think of, him walking down this line. So we need, of course, a number that represents that. So just where you know, okay, when it comes to a graph, you can actually take the coordinates and plug them in here if you'd like. However, with a graph, if you remember rise over run, that's way easier when you have it graphed in front of you. So here's what I'm going to do. All right, on this, step 1, I'm going to go ahead and just label it rise over run. That just gives me an idea. It's a ratio that I'm going to go ahead and create. So now remember, rise is the rise is the change in vertical. So in up and down. So going from one point to the next. So the change here is, I can just count. It's going down, and that's actually important. Down 1, 2, 3, 4, 5, 6, 7, 8. See, notice how I went down even with that. I went down 8. So down in the case of this, up would be positive, but down is negative. So I went down 8. Then from here, I'm going to go ahead and go over to the right 2 times. So I run twice. That run, remember, is the change horizontally. All right. So if I want to do that, I would just say step 2 is find out your vertical change. If it's going down, it's negative, of course. And you can put a little star by that too. Just kind of remember that. And then step 3 is from where you were, you run 1, 2. All right. And that's, of course, where I got that bottom number. Okay. And then step 4 is like almost anything we do here when it comes to ratios or fractions. We're going to simplify. I'm going to go ahead and divide both top and bottom by 2. And I get negative 4 over 1, which of course is a slope of negative 4. All right. So what I'd like you guys to do is go ahead and I want you to try out in your book problem 16. Problem 16. All right. I'll give you guys about 30 seconds. Go. Okay. Next, go ahead, turn to your neighbor, and go ahead and share your answer. Go. Okay, so here we go. If we follow our steps, right, I'm going to go ahead. Again, I'll write my ratio, my reminder of rise over run. Okay, remember rise, so step 2 is the change in the rise, meaning going left to right. What's going on when it goes vertically? So going from this dot to this dot. If I'm going from here to here, I'm going to basically rise once before I have to run. I rise once, so that would be 1. Okay, our run from here, of course, is 1, 2, 3, 4, 5. And our answer, of course, is 1/5. All right, can't reduce it, right? Can't simplify it. That's our slope. Okay. All right, the next problem is what happens if they give you, like number 20, they don't give you the graph, they give you the points. Okay, so here's what we're going to do. We're going to go ahead, and if you remember right, to find the rise, you'd find the, of course, difference of the vertical, right, up and down, and that's, of course, what the difference in the y's are, right, because the y-axis runs up and down. So you want to know what's the difference in the y's. So if I'm going to do this, all right, I'm going to go ahead, and I'm going to go and step 1. I'm going to go ahead and get my 2 y's and say, in this case, 3 minus 7. Remember the y, remember x comma y. So don't, be very careful. It's the second number of your ordered pair. So I'm going to subtract the first y minus the second y. Then what I'm going to do is, and be very careful of this, whichever order you do it, you need to make sure you stay consistent. So if it's the first y minus the second y, then you need to make sure that the run is the first x, -1, minus the second x, which is, in this case, -1. All right. So, of course, that was step 2. And then, of course, the third thing is go ahead and compute or get an answer here. 3 minus 7 is -4. And this case, double negative, right? And a -1 plus 1 is actually 0. So here's the thing about a slope. Okay? You cannot say this is a 0 slope. A 0 slope would represent if a little man was walking horizontally perfectly. Okay? Nice easy stroll, nice easy walk. That's because that would be a 0 slope. This would be something like 0/4. However, I don't know how many of you can walk that, right? What they call this is something like that. What they call this in math is undefined. And that would be your answer. Okay? So to be able to do this, you would solve it the same way. Most of the time you'll get an actual nice slope. Every once in a while you might get a 0 in the numerator. That means that's 0/4, which is a 0 slope. However, if the 0 is in the denominator spot, we call it undefined because it would look like this. All right, so here's what I want you guys to try. Make sure you follow the steps. All right, try out problem number 22. 22. All right, go. Okay, 30 seconds. Go ahead. Turn to your neighbor and share. Go. Okay, so here we go. If we follow these steps right here, step one, right, is we're going to find, remember, the rise is the change in the y, right? So negative 7 minus 9. And then the bottom right here, step 2, is find the change in the x. All right, if you want to do this, y and x, change in the y over the change in the x. So the change in the x, 5 minus negative 3. So step 3, right, is solve or compute here. So in this case, I go ahead and say, okay, negative 7 minus 9. All right, that's a negative 16. Go ahead, get rid of my double negative. 5 plus 3 is 8. And if I go ahead and do this, if I reduce, right, both by 8, I get a negative 2 over 1, or of course, my slope is called, it's negative 2 in slope. Okay, so constant rate of change and slope.